Subpart A of Part 33 of Airworthiness Standards on Aircraft Engines include the general information, which is further divided into 6 parts. First is applicability, which establishes airworthiness criteria for the issuance of type certifications for aircraft engines, as well as the revisions to such certificates. The second is general, which clearly states that all applicants must ensure that the engines in question meet all of the subparts standards. Third part briefly discusses the instruction for continued airworthiness in accordance with the Appendix A of this part. Next, the fourth includes the instruction manual for installing and operating the engine, which discusses approved instructions for installing and operating the engine must be prepared. At the very least, the directions must include installation instruction, operation instruction, and safety analysis assumptions. Fifth part would be engine ratings and operating limitations. For this part, it includes the established engine ratings and operating limitations for reciprocating and turbine engines by the administrator. Sixth and last part would be the selection of engine power and thrust ratings, in which the applicants must choose the requested engine power and thrust rating. Each chosen rating must be for the lowest power of thrust that all engines of the same type might produce under the condition used to determine that rating.
Subpart B, Design and Construction General. 33.11 talks about applicability, general design and construction requirements for reciprocating and turbine aircraft engines. 33.15 Materials talks about the basis of experience or test, ensuring that having the strength and other properties assumed in the data design. 33.17 Fire Protection talks about the minimizing the effect of such a fire. 33.19 Durability talks about the development of unsafe conditions of engine between overhaul periods. 33.21 Engine cooling talks about under conditions in which the airplane is expected to operate. And 33.23 talks about engine mounting attachments and structure. Engine mounting attachments able to withstand limit loads without permanent deformation, ultimate loads without failure, but may exhibit permanent deformation. 33.25 talks about accessory attachment, accessory device, and mounting attachments loaded with the provision of for sealing to prevent contamination or unacceptable leakage from engine interior. 33.27 talks about turbine, compressor, fan, and turbocharger rotor speed by establishing test analysis or combination of both that each rotor will not burst when operating in the engine for 5 minutes. 33.28 talks about engine mounting, attachment, and structure. For Part A, applicability controls limits or monitors engine operation that is necessary for continued airworthiness of the engine. And 33.28 Part B, validation. First part, function aspect, talks about perform intended functions, and part 2 of it talks about environmental limits, not be adversely affected by declared environmental conditions given such as lightning and others. And for the third part or part C, control transition talks about the fault or failures result in a change form of one control mode to the other or another. And moving on, 33.28D talks about engine control system failure, such as the first part will be hazardous engine effect and foreseeable failures of malfunction leading to vocal events. And for part E, 32.28 talks about safety assessment, identifying faults or failures that result in a change in thrust or power transmission of inertial data. And 33.28F talks about protection system must provide reasonable assurance that those operating limitations that affect turbine, compressor, fan, and turbocharger rotor structure integrity. And for 32.28G talks about software that must design, implement, and verify all associated software and obviously must be approved by the FAA. And 32.28F talks about aircraft supply data uh, leading to loss, interruptions, or corruptions of aircraft supply data. 32.28I talks about aircraft supplied electrical power, loss, malfunction, or interaction of electrical power supplied not resulting in hazard engine effect or unacceptable transmission of inertial data. And 32.28J talks about air pressure signals, considering the effects of blockage or leakage of the signal lines on the engine control system. And 32.28K automatic availability and control of engine power for 30 seconds, or OEI ratings, which means the provision for a means for automatic availability and automatic control of 30 seconds OEI power within its operating limitations. And 33.29L talks about engine shutdown means, providing shutting down the engine rapidly. 33.28M talks about programmable logic devices using digital logic or other complex design technology must provide a level of assurance which a method approved by the FAA that is consistent with the criticality of the performed function. 33.20Y talks about instrument connections to ensure that operations of the engine will with any engine limitations with its corresponding instrument. With that part, I am done with my presentation.
For Subpart C, the design and construction of reciprocating aircraft engines. For the applicability, this prescribes additional design and construction requirements for reciprocating aircraft engines. For vibration, the engine must be able to function normally without any excessive stress and vibration. For turbochargers, its case must be able to contain fragments of compressor or turbine in an event of failure. The fuel and induction system includes the following: the fuel system that should be able to supply appropriate mixture of fuel, the intake passages that should be able to minimize the danger of ice accretion in those passages. For the fuel filtering, the applicant must specify the foreign particles passing through filtering and must not critically impair engine fuel system functioning. For the induction system, its passages that conducts mixture of air and fuel must be self-draining. For the fluid injection system, the applicant must show the fuel that fluids other than fuel is properly controlled and flowing adequately. Moving on to the ignition system. The spark ignition engine must have a dual ignition system with at least 2 spark plugs for each cylinder and 2 separate electric circuits with separate sources of electrical energy, or have an ignition system of equivalent in-flight reliability. Lastly, the lubrication system that should be able to allow installing a means of cooling the lubricant and also be able to function properly in all flight altitudes and atmospheric conditions. In case of oil leakage from excessive pressure in the crankcase must be vented in the atmosphere.
Subpart D covers block tests and inspections that reciprocating aircraft engines must undergo. Before an engine undergoes each endurance test as required by this subpart, the adjustment setting and functioning characteristic of each component must be established and recorded first, in which it can be done through vibration test, calibration test, and detonation test. The vibration test establishes the torsional and bending vibration characteristics of the engine shaft as well as the conditions under which the engine can be operated safely in an abnormal state. The calibration test will be the basis for establishing the engine's power characteristics and the conditions for the endurance test specified in Part 33.49. And lastly, the detonation test is for establishing the engine that it can function without detonation and throughout its range of intended conditions of operation. After this series of tests, the engine can now undergo the endurance test. In Part 33.49, the endurance test must include a total of 150 hours of operations in which the engine is subjected to a series of runs, depending upon each specific type and contemplated use. Additionally, the runs must be made in order found appropriate by the administrator for the particular engine being tested. Furthermore, an operation test is also included, as this will be the basis for the operational characteristics of the engine. This includes demonstrating backfire characteristics, starting, idling, acceleration, overspeeding, functioning of propeller and ignition, and other operational characteristics of the engine. As for those engine systems and components that are not substantiated in accordance with Part 33.49 or the endurance test, an additional test must be conducted in order to know that these systems or components perform their functions in all declared environmental and operating conditions. After a series of runs in the endurance test, an engine will undergo the teardown inspection in which it will be disassembled and each of its components will be inspected for the conformity to its characteristics and type design in accordance with the information submitted in the endurance test or Part 33.49. As for the general conduct of block tests, this includes the things that an applicant may follow, such as servicing and making major or minor engine repairs in accordance with the instructions in Part 33.4. Also, this part states that all testing facilities, including equipment and competent personnel to conduct the block tests, must be furnished by each applicant.
Subpart E, Design and Construction for Turbine Aircraft Engines. This subpart prescribes additional design and construction requirements for turbine aircraft engines. Stress analysis must be performed on each turbine engine, showing the design safety margin of each turbine engine, rotor, spacer, and rotor shaft. Vibration. Each engine must be designed not to induce excessive stress in any engine part because of vibration. Pressurized engine static parts. Applicant must establish test for stabilized period of 1 minute, and the part must be exhibit no permanent distortion or leakage. Surge and stall characteristics. Engine must not cause surge or stall when starting a change of power or thrust augmentation, limiting inlet air distortion or inlet air temperature. Bleed air system. The engine must supply bleed air without adverse effect on the engine. Fuel system. Fuel supplied to the engine at a flow and pressure specified by the applicant. The engine must function properly. There must be a fuel strainer and a fuel injection system is adequately controlled. Induction system. Icing. Each engine with all icing protection system must demonstrate method for specific icing condition. The following is a table for specific icing condition. Ignition system. Each engine must be equipped with an ignition system for starting of engine on the ground and in flight. Engine life limited parts. Operating limitation must be established which specify the maximum allowable number of flight cycles for each engine life limited parts. Typically, engine life limited parts includes disc, spacers, hubs, shaft, high pressure casing, and non-redundant mount components. Lubrication system. Each lubrication system must function properly in the flight attitude and atmospheric condition in which an aircraft is expected to operate. The system must have oil strainer or oil filter, oil tanks, oil drains, and oil radiators. Hydraulic actuating system must function properly under all conditions. For safety analysis, the applicant must analyze the engine, including the control system, to assess the likely consequences of all failures. Bird ingestions. All ingestion tests must be conducted with the engine stabilized at no less than 100% takeoff power or thrust. The test includes large single bird, small and medium flocking bird, large flocking bird. For rain and hail ingestion, all engine must not cause unacceptable mechanical damage or unacceptable power or thrust loss after the ingestion. Each fuel burning thrust augmenter, including the nozzle, must provide cutoff of the fuel burning thrust augmenter, permit on-off cycling, be controllable with the intended range of operation. Upon a failure or malfunction of augmenter combustion, it must not cause the engine to lose thrust other than the provided by the augmenter. And lastly, have controls that function compatible with the other engine controls.
For Subpart F, we shall have a general overview of block tests for turbine aircraft engines. The purpose of this subpart is to establish a series of block tests and inspections in which to ensure the quality and safety of each turbine engine. These various tests include vibration, engine overtorque, calibration, endurance, engine overtemperature, and operation tests. In addition to that, there's also initial maintenance inspection, engine system and components, rotor locking, teardown inspection, and etc., which it is a requirement for the airworthiness of an aircraft.
For the last subpart of FAR 33 aircraft engines will be about special requirements, turbine aircraft engines. Its only yet detailed section, which is design and test requirements for early ETOPS eligibility, it discusses about design approval for an engine to be installed in a two-engine airplane approved for ETOPS without testing. ETOPS, for those who don't know, means Extended Range Twin Engine Operational Performance Standards. It is a certification that permits twin-engine aircraft to fly routes at safe time periods from the nearest airport that is suitable for an emergency landing. The other notorious meaning for ETOPS is engines turn or passengers swim. This whole section discusses about parameters, tests, and many simulation service missions needed to be completed, approved, and deemed acceptable by the FAA.
That's about it for the presentation. We hope you learned a lot about FAR 33. Any question or clarification regarding our topic would be entertained by our group. Thank you for listening.